My name is Matt Miller, and this is Lab 3. Introduction. For this lab, we used GoScript to make a computation model to analyze a star's motion around a black hole to find the net force on the star. Using these results, we were then able to calculate the black hole's mass, which was not given to us. We were given the initial conditions of the star's mass and velocity, with the velocity determined by a seed, which was my Georgia Tech email. Some background info. We're going to be basing the velocity calculation on Newton's second law and using the momentum principle to calculate the F-net forces, and we can also use that to calculate the perpendicular and parallel forces. We'll then use the Fg equation to calculate the mass of the unknown body, the black hole. So let's get started. We'll first estimate the momentum based on the initial calculations, and we'll calculate change in momentum, Pf minus Pi, and change in time, Tf minus Ti. The Fnet is then found by the delta P divided by delta T, which also equals Fnet. Then we were going to solve for the mass of the black hole in the Fg equation. dp dt is found doing the magnitude of the momentum divided by the time, dt. P hat equals Fnet parallel. We can then rearrange this to solve for the parallel force by subtracting Fnet, or subtracting the parallel force from the Fnet. So here's the code. I changed the g constant to 6.7 e to the negative 11, the star's mass which we were given, and the time delta t was changed to 1 day, 60 times 60 times 24. I then went into the while loop and updated the equations to find the velocity, the momentum, sorry. And then we updated the rest of the delta v, delta p equations, and then set that equal, or set dp dt equal to delta p divided by delta t. Fnet then was set equal to dp dt. The parallel and perpendicular forces were found by calculating p hat, which was p initial divided by the magnitude of p initial, and the perpendicular was found using that as well. Fnet parallel is equal to dp dt parallel, and the same is true for the perpendicular force. Or we solve for the perpendicular force by subtracting dp dt minus dp dt parallel. Fnet perpendicular was then set to that value. Then we calculated the black hole's mass by rearranging the Fg equation at the end. So here's the simulation, and as you can see, the different arrows are the magnitude and the direction of the parallel, perpendicular, and normal force, Fnet. So the mass of the star was 2.0 e to the 30, and the mass of the black hole that we found through this computational model was 1.41712 e 34 kilograms. Just comparing the star to the size of the black hole is 7,085.6 times larger than the star. So what does it mean? What does it mean if we were comparing net force and its parallel and perpendicular components to dp dt and its perpendicular and parallel components? So net force and dp dt are equal to each other. However, they are two separate values. dp dt is the change of momentum with respect to time, and Fnet is simply the presence of a force and what that value is. So when we were asked what if we replaced the mass of the black hole that we found and another black hole was put in the same location but with an unknown mass, and the apparent motion of the star did not change, can we still solve for that mass of the new black hole? If the mass of the old black hole was switched out with a new mass of a new black hole, and there was no apparent change in the star's motion, then all values must be the same. If the mass of the black hole was any different, we would notice a change in the star's motion. Thank you.